Hello, my Algebra 2 friends. So we're back with a lesson. This is technically a review lesson, but it's been a while. We're going to talk about exponent properties. So first, let's get some vocabulary under our belts. My pen will work. We're back. So some vocabulary under our belt. This is read as 2 to the 5th power, which we know means 2 times 2 times 2 times 2 times 2. So we use that exponent notation to give us a shortcut for either how we're going to enter it on our calculator or how we're going to write it in our math. The base is referred to as 2 in that problem, so it's the number that's holding the exponent up. And make sure you're watching your handwriting on these questions, because if it's an exponent, I expect to see it small, and it needs to be superscript, so like in the exponent position, just like you would see it on your calculator. So here are the properties of exponents, and these names are not important, but this property right here states that if you have the same base and you're trying to multiply your bases together and they happen to have exponents, what you do is you keep your base, but you add the exponents together. So I think it would be very smart of you to make a little note somewhere on your notes that we are adding those together. Another property, the power of a power. Raising an exponent to another exponent. The quickest way to simplify that statement would be to multiply. And there's some examples off to the side here. If you have a product within a parenthesis set, so something times something else, and that could be coefficients or variables or anything, and this is being raised to a power, you can distribute that power to both of your bases. The negative exponent property is probably the weirdest one. Basically, anything with a negative exponent is on the wrong side of the fraction bar. So if it is in the numerator, you could move that term to the denominator, and then it would turn to a positive exponent. So this very simplified example here is just showing like a singular number a to the negative m power. We could flip that to the denominator. So what I like to write down for that problem, as far as like a trigger word to remind me of what to do, I'm just going to write the word move. A negative exponent indicates that a term has to move to the other side of the fraction bar. Now, this little note here about a not being equal to 0, that's just because you can't divide by a 0. So they have to stick that on there, but I don't think any of us would have thought twice about that. All right, speaking of 0, anything to the 0 power is equal to 1. For some reason, kids get this one confused. You do have a calculator, so if you're ever second guessing yourself, like, oh man, is it 0, is it 1, is it something else? Just type any number to the 0 power, and you'll see that it comes out to 1. The only exception to that, again, is if a was actually 0 itself. You can't take 0 to the 0 power, it comes out as 0, it's weird. All right, so we have another property down here that states if you're trying to divide two of the same base and they happen to have exponents, you can keep that base, but you can subtract the exponents. Again, it's got that weird a cannot be 0 thing, just ignore that for now. And then if you have a division problem, two different bases, but they're both being raised to a power, you can once again distribute. I'm just going to write DIST, to mean that I could distribute that power to both of the bases. So there's some numerical examples off to the side there on this box, and we're going to be seeing kind of a mixture of numerical and also variable expressions that are involving exponents. So it's not as simple as, oh, I'm just going to type it in my calculator, because you can't do that with variables. So one thing I like to do, and if it isn't already done for me, I might do this anyways, I would rewrite all of my problem with little multiplication dots in between all the terms, because I think that really helps kids remember these are all different bases. And the first thing I'm going to look for is, are there any coefficients in this problem? There's one coefficient in this problem, and it's a 4. So whatever my final answer is, it's going to have 4 in front of it. Now we're going to kind of collect like terms, but the idea is these properties work for when they have the same base for some of these properties. Like for instance, this one here, where we add the exponents together, only works if you have the same base. So for instance, I've got x squared and x to the 4th, and we're supposed to add these exponents together. And think of it as like a counting problem. X squared means xx, and x to the 4th is x times x times x times x, and if you kind of counted all those up, you'd have x to the 6th. So these properties are nice because they just give you shortcuts. And then same property, but this time it's being used on the y's. So again, we've got y to the 2nd and y to the 3rd, and we're supposed to add those exponents together for those common bases, and we get y to the 6th. All right, in my effort to make this really pretty and colorful, I forgot how to add. That's not 6, that's 5. Whew. All right, number 2. Now this time we got to be careful. There are 2 coefficients hiding in this problem. We have a 3, and then later on there's a coefficient of 2. So my true coefficient is 3 times 2. Those are not exponents. Those are just simply coefficients. That coefficient is a 6. All right, very similar to the last question. You got a couple of x's. We would use that property where we add the exponents together. Let's see if I can add properly this time. This is x to the 7th power. And then again, the y's, same property, just a different base. Let's see, y to the 8th power. I'm all nervous now. Like I can't add. Summer, man. All right. Power of a power. When you have a problem that has a power and then outside of that problem there is another exponent, you are supposed to multiply those together. So you don't do anything to the base. You're just going to keep that as an x. But you are going to multiply these powers together. So this becomes x to the 6th power. Similarly over here, keep that x, and then we're going to multiply those exponents together and get a 15. So that's a pretty simple power property. Unfortunately, in Algebra 2, we don't usually have problems where there's like one property. Usually there's a couple of properties. So let's talk about power of a product. So we've got a power, but inside of the parentheses, there's actually a multiplication problem. So this is the one where we have to distribute it to both of the bases. So we're going to distribute the 3 to the 2 and also to the x. Now here's an example of more than one property. 2 to the 1st is the same thing as 2, right? So if I were to multiply the 1 and the 3 together, right now I'm going to write that as 2 to the 3rd power. We'll come back to that in a minute. But for the x, we're supposed to multiply these exponents together because when you take a power to a power, that last property, you're supposed to multiply them, right? So that becomes x to the 12th. And technically, I actually like this answer. This is beautiful. The only thing you might want to simplify is what 2 to the 3rd power is. Well, that's either a calculator or from memory or just think about it real hard. 2 times 2 times 2, that's an 8. So the best answer to this question is 8x to the 12th power. All right, same idea here for number 6. We're going to distribute this 4. We just can't forget that he's going to everybody, including the coefficient. So remember, there is a secret 1 on that 3. So 1 times 4, this is now 3 to the 4th. We'll come back to that in a minute. And then x squared being raised to the 4th power, we're supposed to multiply these exponents together. So we're keeping the x, and we're going to multiply those together, and it becomes x to the 8th. And then same idea for the y's, this becomes y to the 20th. Technically, this is a good answer, but we can make it a little better. 3 to the 4th power, that one you might not have memorized yet, but, you know, this is not my first rodeo. 3 to the 4th power is 81, and then x to the 8th, y to the 20th. You could easily type that on a calculator. You could do it mentally by taking 3 times 3 times another 3, and then possibly doing some like arithmetic on your paper times another 3. It's 81. Just trust me. Or not. Okay, negative exponent. Remember, anybody who has a negative exponent needs to move. That was our word for negative exponents. So as I look at this problem, this is a good example of there's going to be more than one property going on here. First of all, I noticed that this has a negative exponent, so it's going to move. And once I move that term, it becomes a positive exponent. However, there's another property going on here, guys. We got x to the 3rd, we got x to the 4th, and we got x to the 6th. And those are all up in the numerator, and they all have a base of x. So we can use that very first exponent property that says I'm supposed to add all those exponents together in order to simplify. They're going to stay in the numerator, and that's going to become x to the, come on brain, 13. And then remember how we moved that y term? So now down in the denominator, you've got a y to the 2nd power. X and y are 2 different bases. We can't do any further simplification, and that's fine. You may have gotten to that same answer by doing steps in a little different order, or maybe more steps. That's okay. That's the beauty of exponent properties is, you know, the order doesn't matter in how you simplify them. Sometimes it's easier one way or another, but we'll figure that out. Okay, so here, watch out. There is a coefficient. This coefficient of 7 is just going to kind of stay because it doesn't have a negative exponent. However, I do notice there's a couple of things here that would need to move. For most kids, they like to move terms around and then deal with non-negative numbers because negative numbers really freak kids out. We'll talk about this problem again in a moment. All right, so keep the 7 where it's at, keep that x squared where it's at, keep this y to the 6th where it's at, but we just move the y to the third to the bottom. I'm going to move it over here, actually. And then we move the x to the fifth to the bottom. Okay, the reason I purposely lined them up that way is because now we're encountering some other property that we haven't talked about yet, other than the discussion of the property itself. When you have the same base and you're trying to divide those bases and they happen to have exponents on them, what you do is you keep that base and you subtract the exponents. So I'm going to write myself a little note. I'm going to subtract, and you got to be careful, you're subtracting the numerator minus the denominator. So 7, nothing happened with 7. 2 minus 5 is negative 3. I'm going to write down, I should do it in green, I'm going to write down x to the negative 3. Notice I wrote it up with the 7. We'll talk about that. And then 6 minus 3, this would be y to the 3. So now you're looking and you're like, wait a minute, I'm not done. Because there's some property out there, right? It says negative exponents need to move. So this guy right here, once again, I got to use that moving property. And that only arose because that's the way I chose to simplify this question. I can guarantee if we're doing this live in class, and this is now positive, if we're doing this live in class, it's probably not the order in which kids told me to simplify this, and that's fine. That's the beauty of this question. Let me kind of, a little crooked line there, I guess. Way back at the beginning. If we were in class, I would have called on somebody to give me an idea, and I have a feeling somebody might have said, hey, why don't you just combine some terms together using that adding property? So everything up in the numerator right now, you could have combined all the x's, and you could have, I would say, combined the y's. Oh, yep, there's 2 y's there. And look at what you have. So you would have had 7 still. And then we got x squared, x to the negative 5th. So that's x to the negative 3rd. And then y to the negative 3rd and y to the 6th. If you add those together, you get y to the 3rd. And then guess what would have happened? We would have done the same work, right? We would have taken this x to the negative 3rd. We would have moved it. And we would have eventually got that same answer. So there's definitely not just one way you can do these questions. And your neighbor, you might do 2 different methods and get the same answer. You will get the same answer if you don't mess up, and that's great. In fact, there might be a moment in your future where I ask you to do the problem more than one way. Show me that you can still get the right answer, even by going in a different order. Fun. So that brings me to another point about a checklist. We call this our exponent checklist. This problem was confusing to a lot of kids when they first saw it in Algebra 1 because they're like, oh, when am I done? Like they feel like once they make one change, they should be done. Well, exponent problems are not done until a few rules have been satisfied. So the first rule I might want to write down is that we have to have no negative, it says negative, exponents. So if I'm looking at my problem and I still have negative exponents, we got a problem. Another rule that we have to follow is that I cannot have any parentheses. I think that's how you spell parentheses. I'm a really bad speller. All right, the plural version, not parentheses, parentheses. I don't know, whatever. Correct me on the internet. And then the other rule is all terms combined. So you can't have like 2 x's in the problem. You can't have 2 different coefficients. They got to be simplified. You can't have 2 different y's. And once you've gone through this checklist and you're like, yes, yes, I satisfied all these 3 rules, then you know you're done. So how we get to the final answer, depends on how crafty you are. Okay, this question, we don't have parentheses, so that's cool. We don't have any negative exponents, so that's nice. But we do have a situation where there's not all like terms are combined. So I have a coefficient of 3. I don't see any other coefficients. I'm just going to write that down. What they do want to illustrate to you on this question, though, is this guy right here. Kids freak out anytime 0 shows up in math because they're like, what does it do? Zeros do weird things. Well, the 0 property states that anything to the 0 power is really equal to the number 1. So as far as our math goes here, this is like 3 times x squared times y squared times 1, which does nothing, times y to the 3rd. So for now, basically I'm just going to ignore it. And I'm going to combine my other numbers using that other property. Normally I would say, oh, I'm going to add the x's together, but 0 doesn't do anything, right? So this is x squared. And then, where's my y's at? Oh, lovely. Y to the 6th. And again, same checklist. Everything's combined, there's no parentheses, and there's no negative exponents. So we be done. Favorite question of all time. And kids still get it wrong. The rule is anything to the 0 power is equal to 1. So this question, the answer is 1. Not 0. Not anything else you think it is. It's 1. All right, we actually kind of talked about this question a little bit ago by accident, just because of the way I simplified this question a couple questions ago. When you have the same base and you're trying to divide them and they happen to have exponents, you are supposed to subtract the exponents in that exact order, numerator minus denominator. So whatever your answer is, so x to the whatever power, it defaults up to the numerator. Some of you are very good with algebraic manipulations, so you can kind of see how everything's going to end up simplifying to without doing a lot of thinking. That's great. But just as a rule of thumb, when you do the subtraction rule, whatever your answer is, it pops back up into the numerator for now, possibly forever. All right, so x to the 5th divided by x to the 2nd, you would subtract those exponents and you would get x to the 3rd in the numerator. And then y to the, subtract those exponents, you get y to the 1st in the numerator. That's important, okay? If you put over a 1 to indicate they're in the numerator, that's fine. It's just weird. This is your answer. All right, number 12. Ooh, careful. There's a sneaky 1 right there that they didn't write down. So when I go to subtract my exponents here, that becomes x to the 3rd in the numerator. And then here, this is what I was worried about. When I subtract these exponents, I get y to the negative 3rd in the numerator. So now I have to use that weird rule that says anything with a negative exponent would have to move to the other side of the fraction bar. So this y has a negative exponent. Now notice, I'm not moving the x with it. The x to the 3rd stays in the numerator. And then now it's over y to the positive 3rd power. Which this is my final answer, huh? Lovely. Again, I know there's some of you out there who are like, ugh, I could do that all in my head. That's wonderful. It's about to get real weird, and you probably won't want to do it all in your head pretty soon. Okay, so here we have probably more than one property, but one of the properties they really want to hit home here is the power of a quotient. So you're going to have a division question with a power outside of it, outside of it, and we have to distribute that power. And it goes to everybody. That's why we like to put the little dots in between. So 3 to the 3rd, this becomes x to the 3rd, and then think about the property of a power to a power. We multiply those together. So this is now 3 to the 3rd times x to the 3rd over y to the 15th when we multiply those together. That's actually an okay answer. Not the best answer though, because 3 to the 3rd, 3 times 3 times 3 is 27. So the best answer is 27, x to the 3rd over y to the 15th. That's the best answer. Look at that. All right. Again, in class, you guys would probably guide me through this question. I don't even want to guess what you would normally do. It's all right. We'll go ahead and distribute it. And then I know you're out there, you're like, no, 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 don't do it. We'll talk about that. All right, same idea. So now we've got 5 to the 4th power. Ooh, I gotta think about that one. All right, and then we've got x to the power to a power. We're supposed to multiply those together. So that's now x to the 12th. And then y to the 24th. And this is what you guys were all trying to warn me about out there. I also have a y to the 8th on the denominator. So we're not done. Besides the 5 to the 4th issue, there's 2 y's in the problem. So now it's not the end of the world, guys. We just keep simplifying. We need to use that property where we subtract the exponents now. And then while I'm simplifying, let's go ahead and change 5 to the 4th power. Okay, think, Abruzzo, think. 5 to the 3rd is 125, so times another 5 would be 625, I think. If I'm wrong, I apologize. So 625, x to the 12th. And then I should be able to subtract 24 minus 8 would be y to the 16th. Okay. I son wants y'all to know it is 12:22 on July 9th. All right, there's our final answer. Okay, what if we throw them all together? We kind of have been doing that, but this is more typical of what you're going to see on your practice work. There's not one right, wrong answer. Oh, going back to that last question. We could have simplified these y's first before we distributed. That's what I was trying to get to. Hey, Log. Say hi.
Hi.
We're recording. This is going on YouTube, your favorite. All right, so again, more than one way to approach this question. For most kids, they like to knock out those parentheses before they get too deep into a problem. So they would distribute this. Now, Logie, you're only in first grade, so I don't think you know this answer, but I got to. I was about to enter second. -2 times 6. Well, that's a -12. And then for the b's, or the b, 4 times 6 is a 24. And then we have a rule, Logan, that anything that has a negative exponent, so any of these top numbers, if they're negative, they have to move to the other side of the fraction bar.
Okay.
So this a to the -12 is going to have to move. So we've got b to the 24th. That's going to stay where it's at. And then now we've got a to the +12th, because once he moves, he's happy and he's no longer negative. It's nice. Oh boy, number 16. This really gets kids because we've been working on exponent properties and they're so used to, okay, bye. Already bored. They're so used to doing exponent properties, they forget what to do when you just have a regular old number. If you had 8 divided by 4, those are coefficients, right? 8 divided by 4 is 2. So that's the coefficient. It is a 2. You can write 2 over 1 if you like, but you can surely just write 2. Alrighty, a to the 6th, and then later in the problem it's being divided by a to the 4th. So we're going to subtract this. I'm going to write a little note to my readers out there though. This coefficient we just reduced. So if we subtracted a to the 6th divided by a to the 4th would be a to the 2nd. And there's no other c in the problem, so I'm just going to leave it as c to the 9th. And y'all, we're done. I don't even need that 1 in the denominator. So, what you doing, buddy? Okay. You can lose that denominator of 1. Oh boy, there's a lot going on in this one. We've got this power of a power thing that we have to distribute. I'm going to use a different color, though. Really burn your retinas with red ink. Here we go. That only gets distributed into anything that's in the parentheses, so it won't go to the denominator this time, so be careful. So right now, we're going to end up with, hey, don't do that. X to the 8th. Y to the 12th. And then our denominator is still an x to the 3rd, y to the 2nd. So now we're going to use that rule where when we have these common bases and we're trying to divide them, we end up subtracting their exponents. Our answers go to the numerator by default. So this becomes, let's see, x to the 5th. You could have done that for me. 8 minus 3. 5.
I don't want to do math because I just do a whole bunch of math.
I understand. Your brain hurts from all that math. And then we got 12 minus 2, which is y to the 10th. You really don't want to do that math, do you? You know what?
I don't know what we're doing. I haven't had a single thing.
Okay. All right, number 18. Oh boy, oh boy. Be careful on 18. I get a lot of kids who know to distribute to 3, but they just don't go big enough. This 3 gets distributed to everybody. The 5, the x, and the y. So this becomes 5 to the 3rd. We'll talk about what that could be called later. And then we got x to the 3rd. And then because y to the 4th is also being raised to the 3rd, that becomes y to the, I got to multiply those, so y to the 12th. This is actually a good answer. I wouldn't mind if you left it like this, but a better answer would be if you simplified y to the 5 to the 3rd, excuse me. So that's 125 x to the 3rd over y to the 12th. This is crazy stuff, isn't it, Logan? Mm-hmm. Mm-hmm. This is what you're going to do when you're like a teenager. Fun, right? Okay, there's that cool rule out there. Don't forget it, guys. Anything to the 0 power is equal to 1. So that right there, that whole numerator is a 1. Be careful though, that doesn't affect what's in the denominator because it wasn't in the same set of parentheses. So here you need to multiply this together. And then sometimes kids get this one wrong because they don't realize that this is in the denominator. So you have a 1 in the numerator and you have x to the 15th in the denominator. That is your final answer. If I go through my checklist, no parentheses, no negatives, and everything's combined. Perfect. Perfect answer right there. Oh, and that was the end of my lesson. So, time to get the glue to stick in your brain here, guys. You got to practice these. No single problem is alike to any other problem in exponent rules, and you can be doing them a whole bunch of different ways. So, don't feel like you're doing it wrong. As long as you follow the rules of exponents, you cannot get it wrong. You're bored. All right. Bye.